8.3 question 3 is a hydrostatic pressure question. So to start off, what we're going to do is this question is actually hydrostatic force. So we're going to want to write down what our force formula is. So force is equal to the weight of the liquid from the bounds from bottom to top multiplied by h of y multiplied by L of y times dy. So the weight of our liquid is going to change depending on what liquid it is, but since it's water, and since we know it's in feet, depending on the textbook, it's either going to be 62.4 or 62.5, but for this example, we're going to use 62.5. And now, to find the bounds of integration, what we're going to do is we're going to set our line, our x-axis, to the top of the object, wherever the arrow is. And we're going to set the y-axis to the left side of our object. That's going to be our y-axis, and this is our x-axis up top. So because of this, our height now is going to become -3, and the height of the entire object, right here, is going to be -11. So we can use those now as our bounds of integration to make the integral go from -11 to -3. And since we put our x-axis right at the top, we don't have to worry about all the silly things for the h of y. We can always just make it -y no matter what, because if you look at it, no matter what this imaginary line is, it's still the height of that line is always going to be is -y. So we're here. I'll put this in a different color. Make it orange. No matter what, let's say we're right here. This is still going to be -y. We're going to have a line here. No matter what, this is still -y. It never changes no matter what. So since we put our bound at the top, it makes it nice and easy, always -y. If you made the bound at the bottom, however, it would make it a little bit more difficult. That's why we're going to do it this way. And since it's a rectangle, it's going to have the same width the whole entire time. So it's just going to be whatever width they gave you, which is 2 in this case. Now, to make it fully integrable, you're going to take out the 2. You're also going to take out the negative from the y. So it's going to be -2 times 62.5. And now it's just the integral from -11 to -3 of y. Okay, I just cleaned it up a little bit. Now we're going to do our integration. So it's going to be -2 multiplied by 62.5. And this is just going to be a simple integration, which is going to make it y squared over 2. And then the bounds are still -11 to -3. This then becomes -2 multiplied by 62.5, all multiplied by -3 squared over 2 minus -11 squared over 2, which should give you the answer, which is 7,000. Okay, question 4. This is going to be finding the hydrostatic force acting on this triangle. So in the textbook, it says it's in feet, but instead what we're going to do is we're going to do it in meters, just so we can see what that looks like. So we're going to set up our integral like normal. Force is equal to the weight multiplied by the integral from c to d times the height changing of the object multiplied by the length changing of the object. Never forget the dy. So since this weight is a little bit different, what we're going to have to do is it's going to be either 9.8 multiplied by 1,000, the 1,000 being the weight of water in meters, and this is going to be gravity. So this can change depending on what your teacher asks, because this could be 9.81 or just 9.8, but all you have to do is remember that if you see meters, it's going to be either 9,800 or 9,810 because of the gravity and the way the water multiplied together. Now, what we're going to do is we're going to find our bounds of the integral. So what we're going to do is the same thing as last time. Set this to our x-axis and set the y-axis to the left side of our object, no matter what it is. This is going to become y. Now, this will be negative 2 meters, and this is going to be negative 7 meters. So, nice and easy, negative 7 to negative 2. Now you have to remember, we're going to be trying to find the force on this little line right there. It's so small that you can't see it. So, because of this, we set our bounds up top, our x-axis up top, so that no matter what it is, this height randomly will always be negative y. You don't make it difficult on yourself, just always make it negative y. Now, this is where it gets a little bit more difficult because we have to find the L of y, which is obviously harder because it's a triangle, and you can see that, I'll put it in purple, this length right here, or width, is different than this width. So we actually have to find the change in width, not just put 10 like the rectangle question. So to do it isn't too bad, however. So this point right there is going to be, well, since this is our x and our y, we already know those two, it's going to be xy, which is going to be 0, comma, negative 2. And this one, we know the length of it to be 10, so we know our x is 10, and we know our y, because we know how deep it is from finding our bounds, is going to be negative 7. So now, all you got to do is find the slope of m is equal to y2, so we'll call these x2 and y2, and this x1 and y1. So it's going to be y2 minus y1 over x2 minus x1, which just gives you negative 1/2. Finding the slope isn't just good enough for us, however, what we will have to do is we're going to have to do this slope, or whoops, it's going to be y minus y1 is equal to m multiplied by x minus x1. And for the triangles, this will work, which will always get you to where we need to be, because if you notice, we're in terms of dy, which means we're in terms of y. So we need to find the equation as to y. This is the same as y equals mx plus b, but in case you can't find the b, this just makes it easier for you. So it's going to be y minus negative 2 is equal to negative 1/2, and this is nice and easy because x1 is just 0, so it'll just be x. Now I'll just clean this up. Okay, so now we're going to become, this is just going to be y plus 2 is equal to m at x. But since we are in dy, we need to have the function with y. So we need to solve for x. So just divide both sides by m, but we remember m from before is negative 1/2. So it's going to be y plus 2 is equal to negative 1/2 x. Makes this nice and easy for you. It's going to be bring the 2 up, multiply both terms by 2. So it's going to be 2y plus 4 is equal to negative x. So negative 2y plus 4 is equal to x. Now what you're going to do is this right here, solving for x, is what's going to go into our integral before. So this is going to be negative 2y plus 4 times dy. To make this nice and easy, because there's all the negatives, don't want to confuse anyone, just take this negative out. Make it negative 9800 integral of negative 7 to negative 2 multiplied by y times negative 2y plus 4 multiplied by dy. So now, shove the y in there, make it negative 100 from negative 7 to negative 2 of negative 2y squared plus 4y times dy. Okay, so I have it rewritten here, and it's a nice integral again because it's addition, nothing too crazy. So it's going to be negative 9800, and then we can skip ahead here because we already know what we're going to do. is going to be negative 2y cubed over 3 plus 4y squared over 2. And then we're going to have our end bounds. Erase that. And we're going to have our top and bottom of negative 7, negative 2. Now this gets a little bit longer because of the addition. Was nothing too complicated. If you have a calculator, that could make it a lot easier for you, but we're going to do it without that today because we don't need it. It's going to be negative 2 cubed over 3 plus, and I have a second bracket in there too, 4 negative 2 squared over 2, end of the first bracket, minus, start a second bracket, negative 2, negative 7 cubed over 3, plus 4 negative 7 squared over 2, and the second bracket, and the third bracket. We got a little bit messy here. We're gonna move this negative 7 out of the way. Just put it up a little bit more. There we go. Okay. Now, all you gotta do, shove this into a calculator or an online thing like Maple, and it'll give you your final answer, which should be around 8333.3 repeating.